Hi guys and girls on YouTube, welcome to my channel. I've just got a quick video here because we're in the middle of summer, so I'm spending quite a lot of my free time outside, so I don't have a great deal of time at the moment to make videos, but I thought I'll just run you through this quick video because this is quite interesting, and this is a problem that's quite often it's overlooked. So let's just pick up the camera. And what we're looking at here is a Samsung microwave. It's a commercial microwave. It's a CM1919. But this tip I'm going to give you also applies to the CM1929. In fact, it can apply to any industrial or commercial use microwave oven. So the customer's brought this in. It says it flashes an error code on the front. Now I plugged it in and it works absolutely fine. He couldn't remember what the error code was, but the usual error codes are E41 or E42, and that can relate to quite a few things. It can be these switches, it can be these relays here, or sometimes it can be these 200k resistors in the power sensing circuit, so it thinks the magnetron's not running. But like I say, I've tried this over and over again and it works absolutely fine, but I have been caught out with this before, so let me just run you through. I've got a quick demonstration here because I know everybody likes demonstrations. So in a situation like this, the most sensible thing to do would be to check the two monitor switches here and the power switching micro switches there, because these when these microwaves running, they're running over they're drawing more than 14 amps from the mains, so you've got a huge current draw passing through these switches and these relays on the top. So let's just do a quick demonstration. It's not on this particular microwave because I have done one earlier with this fault, and I'm going to show you. Right, so this switch here, this was removed yesterday from a microwave. This is a brand spanking new one. Now what we're going to do is we're going to measure the contact resistance of the terminals when the switch is closed. Now to do this on a flute meter, what you need to do, because if we turn it on and just short the test leads together like that, you can see we've got the lead resistance of 0.5 ohms. So what you need to do is you need to press the rel button there, and that cancels out the resistance of the test lead. So now we can measure more or less absolute zero. Well, I say absolute zero, we can't measure in the milliohms range, but this will give you an idea. So let's first check the reading on the brand new switch. I'll pick the camera up. So that's the brand new one there. I press the switch. Well, press the rel button so we can measure down to zero, and that is absolutely fine, which is what you'd expect because it's a brand new one. Now let's measure with a milliohm meter the contacts of this when it's closed. Right, so same test again, but we're looking a lot deeper now into the contact resistance when it's closed with this milliohm meter. So press the button, and we've got a contact reading of about, I don't know, 10, 11, 12 milliohms. Yeah, well, let's just call it about 12 milliohms on that. Right, well, now I'm going to do exactly the same test again with this switch I've removed from a microwave. So if you look at that, press the button, and that switch looks absolutely perfect. Let's put this switch on the milliohm meter now. Here we go, same test with the milliohm meter. Press the button, and we've got a contact resistance of about 80 milliohms, which is actually very, very low. Even though it's not as low as the brand new one, that's very, very low. You wouldn't pick up that difference on an ordinary multimeter. So what do we do now? We've checked this switch and it looks absolutely fine. A contact resistance in the low milliohms. You'd expect that anyway, because it's not brand new anymore, is it? It's been used. So what do? Do you think maybe the switch is alright? I've tested it, works absolutely fine. That is the big mistake. Let's just put the camera down there and I'll show you what you do next. You pull off this, which is actually quite tight, and then you look at these contacts here, and can you see that one there? That's burnt, so there's evidence of arcing there. Now don't forget, these commercial microwaves, when the pub, restaurant, chip shop, they might be going all day long, so the longer they run, these contacts actually heat up, and that's where you get your error code from, because eventually you get an intermittent contact there. Now obviously when it cools down, it tests just like I've shown you absolutely fine, but that is without a doubt the cause of the problem. The contacts burn. Now it's no use just putting a new switch in. You need to cut that off and put some new terminals on, because these will be actually burnt inside where you can't see them. There's no evidence of any burning there, but they will be burnt inside, so you need to replace this and the switch at the same time. But yeah, that's your problem. It's easy to test out the switch and think, yeah, that's absolutely perfect. That is not the cause of the intermittent fault. Let's just bend that over and then you can see it better. Just hang on. Just put that down a minute. And bend it over with my expensive Limstrom cutters. I don't want to break them though. That's better. I'm trying to get a good angle so you can see it. Now you can see a lot better there. Right, so that's my tip for the week. You get any of these commercial microwaves in, check all the contacts on the switches, even if the switches test alright. You even need to pull these contacts off these relays and check these. So there we go, guys and girls. Many thanks for watching this quick video, and I'll catch you in the next one. Okay, goodbye.